Okay, so good day again. This time we're on sample problem number 4. Again, this is a problem to be solved by slope deflection method for a continuous beam. But this time, for this sample problem, the beam has support settlements. Okay, so the supports displaces downward or nag-yield yung mga supports. Okay, so let us analyze this continuous beam. So we have a continuous beam, hinge, roller. So we have 3 spans. Then it is uniformly loaded with 32 kilonewton per meter. The span is 5 meters for each segment. Okay, so the EI values were given and these are the support settlements. Support A doesn't yield, so 0 ang settlement niya. Yung support B, bumaba siya ng 15 mm, so it yielded downward by 15 mm. Yung support C, 36 mm. Yung support D, 18 mm. So these are the displacements. So what would be the effect of these settlements on the moment? So how do we analyze this continuous beam? Okay, again, using slope deflection method, the first step is to identify the member end moments. So assume, again, counterclockwise, positive. Okay, so this is moment on AB. This one is moment BA, moment BC, counterclockwise, moment CB, moment CD, and last is moment DC. Okay, so those are the member end moments. Okay, now so let us identify. So if this is the original position of the beam, let's say this one, so support A doesn't yielded, so the before and after location of point A would be at that point. Okay, yung point B yielded 15 mm downward. So let's say this is 15 mm. So 15 mm. Okay, so this is A prime. Say this is B prime, the final position of support. And yung C is yielded 36, so somewhere here. Let's say here. So here is point C. So the vertical distance here is 36. Then yung D naman is, kung ito 15, siguro yung 18 nandito. This is the final position of point D. So this is the yielding or the displacement of 18 millimeters. Okay? So initially, the beam is horizontal, but before considering the yielding, the settlement of supports, in-exaggerate ko lang, this would be the position of the beam after yielding of supports. Okay, so this would be the exaggerated position of the points on the beam. Okay, so I'm doing this to consider the displacement or the settlement. Okay, so let us solve first for the psi. Okay, for the psi. So psi is delta over L. Okay, so let's say, what is the psi for AB? Actually, the psi for AB is equal to the psi of BA, and that is equal to delta over L. Okay, so may sign convention ang psi. Okay, ang sign convention ng psi is positive siya pagka counterclockwise yung rotation, negative naman siya pagka clockwise yung rotation nung due to settlement. Let's say, kunwari for AB, diba from the original position, ito siya, then napunta siya ron. So ang rotation is clockwise. Okay, rotation is clockwise. Yan yung delta. Okay, that is the displacement created by displacement at B. Sa B naman, from the original position, horizontal, papunta dun. So, clockwise din. So, since clockwise yung rotation yan, negative yung psi. Negative yung sign natin dyan. So, this becomes negative. Okay, ano yung delta? Delta is the absolute value of the difference. That would be 15 at saka 0. So, that would be 15 minus 0, absolute value, divided by L. L is 5 meters. Okay? So, that would be 15 minus 0 is 15 divided by 5. Sorry, this 15 is in millimeters. So, yung 5 should be also expressed in millimeters. So, let's make it 5 meters is 5,000 millimeters. So, that becomes 15 divided by 5,000. So, that is 0.00. So, negative 0.003. So, yan yung psi for member AB and BA. Negative 0.003. Yung negative kasi clockwise. Okay, let's say, what is the psi for segment BC? Okay, the psi on BC is the same with the psi on CB. And that would be delta over L. Now, tingnan mo yung B tsaka C. Diba? From here, it is clockwise. From here, this is also clockwise. So, clockwise, so negative ang sign natin dyan. And that would be the absolute value of the 36 minus the 15. Kasi relative to relative displacement ang kailangan natin. So, ima-minus natin yung displacement between these 2 points. 36 minus 15 divided by the length between these 2 points, which is also 5 or 5,000 millimeters. So, that's negative 36 minus 15 divided by 5,000 is actually negative 0.0042. Okay? Then lastly, for segment CD, that is psi on CD. That is the same with the psi on DC. That is delta over L equals. Now, anong sign convention dito? Ito yung CD, diba? So, from C, paano ikot? O, diba? Counterclockwise na. From D, paano ikot? O, diba? Counterclockwise din. So, again dito negative. Ito, counterclockwise. So, positive na yung sign ng sign natin dito. Kasi counterclockwise na yung ikot nila. Kaya positive. So, this would be positive. The difference, the absolute value of the difference, that would be 36 minus 18. Okay? Then, divided by 5 meters then, 5,000 ulit. So, that would be positive 36 minus 18 divided by 5,000. So, we got 0.0036. So, positive. So, again, ang side dito sa dalawa are negative. Ang side naman dito is positive sa pangatlong segment. Okay, so these are the values of the psi, delta over L. Okay, next step is to write the slope deflection equation. Slope deflection equations. Okay, so ano mga slope deflection equation natin dito? Okay, diba hinge, dulo, roller, dulo ng beam. So, from our sample problem number 3, if you could recall, ito yung sample number 3 natin. Diba, kapag may hinge or roller sa dulo ng beam, the slope deflection equation may be modified by this one. Okay, so let us use this one. Okay, so let's start with MAB. So MAB, that's the moment here. Diba hinge yun, dulo, so the moment there is 0. So 0 siya, automatic. Okay? Katulad ng MDC rin dito, 0 din yan mamaya. But how about for MBA, moment at BA? What is the moment on BA? Using the modified equation, ito yung gagamitin natin yung yung 3. So this one. So what would be our equation? We have MBA. So yung R natin dito, yun yung B. Yung H, yun yung magiging A natin. So that is equivalent to 3EI over L. Theta R is the first letter, so that would be theta B. Minus the psi on BA. Okay? Plus the FEM. The FEM on RH. RH is the BA. Minus kalahati ng FEM. No, here. Kalahati ng FEM ng HR. HR is the AB. So, ayan. Okay, so substitute natin yung mga values. That would be 3 over EI over L. The length of AB is 5. Theta B minus what is psi BA? Psi BA is this one. And that is negative. Okay, so that's negative 0.003. Plus, what is the FEM for BA? The FEM for BA, diba uniform load? So, ano ang FEM pagka uniform load? Diba W L square over 12. W is 32. L is 5 square over 12. Diba? WL square over 12 ang fixed end moment pagka uniform load. Now, anong sign ng fixed end moment sa BA? Yung BA is yun nandito sa kanan. Diba ang fixed end moment sa kanan? Ang fixed end moment sa kanan is clockwise. So, that would be negative. Okay, so negative. Minus 1/2 of FEM sa AB. What is FEM sa AB? Ganun din, diba? 32 L square over 8, over 12. Over 12. Anong sign ng FEM sa AB? Ito yung nasa kaliwa, which is counterclockwise, so positive. So, yan ngayon yung moment equation natin, slope deflection equation natin for BA. So, simplify natin. So, MBA is equal to so we have 3EI delta theta B over 5. Okay? So, this one when multiplied, so 3 over 5 of 0.003. So that is negative is positive. So positive 0.0018 of EI. Then this one. Okay, so this would be negative 32 times 5 square over 12 minus 32 times 5 square over 24. So that's negative 100. Minus 100. So that is our first equation. Okay. Next. What will be our next equation? So A, B, BA. Tapos na tayo. BC naman at saka CB. Moment sa BC. Yung sa moment BC tsaka CB, since interior moments na yan, so balik tayo dun sa original slope deflection equation natin. No, so yung this one, no, so yung 2EI over L. So that would be 2EI over L times dalawang theta B, isang theta C, okay, minus 3 psi ng BC plus yung FEM ng BC. So, yan yung equation natin. O, substitute natin. 2EI over L. L is 5. No, 5 meters. Twice theta B plus theta C minus 3 times. What is psi BC? Psi BC ito. That's negative 0.0042. Yan. Plus, what is the FEM for BC? FEM sa BC, uniform load, diba? So, WL square over 12. W is 32. L is 5 over 12. Okay, yung BC, ito yung BC. Ito yung BC sa kaliwa. So, sa kaliwa is counterclockwise, diba? Ang fixed end moment. Okay? So, that's positive. So, yan ngayon yung equation natin for MBC. Simplify lang natin. This would be 4 EI delta B over 5, 2 times 2. Tapos for theta C, it's plus 2 EI theta C over 5. Tapos ito, 2 over 5 minus 3 times this one. So that's a positive na. So times 3 times 0.0042. Okay, so that would be plus 0.00504. Okay, so EI. Okay, then this one is 32 times 25 over 12. 32 times 5 square over 12. So that's 200 over 3. Over 3. So that would be our second equation. So that would be our second equation. Now, next. How about moment sa CB? Moment naman tayo sa CB. Dito tayo, CB. Okay, moment sa CB is, again, 2AI over L, dalawang theta C, isang theta B, okay, minus tatlong psi sa CB, plus the fixed end moment sa CB. Substitute natin. 2EI. Okay, so we have 2EI over L. L is 5 meters. 2 theta C plus theta B minus tatlong. What is size CB? O, ano yung size CB natin? Ito. 0.0042 negative. Negative 0.0042. So, yung psi plus FEM sa CB. FEM sa CB again is uniform load. So, W L square over 12. Okay, CB. Ang CB ay nasa kanan. CB, nasa kanan, diba? Ano ang direction ng fixed end moment sa kanan? Diba? Clockwise. So, this is negative. Okay? So, yan. So, simplifying this one, this would be 2 times 2 is 4. 4EI theta C over 5 plus 2EI theta B over 5. Tapos ito naman, 2 over 5 times 3 times 0.0042. So that is, negative negative is positive, 0.00504 EI. Then, minus this one is 32 times 25 over 12 is 200 over 3. So that would be our third equation. Yan, MCB. Okay, next. How about for member CD? MCD. O, MCD naman. MCD. Diba ang MCD is a segment with a roller at the end of the support. So, ang gagamitin nating equation for that would be ito, yung 3EI. Ito. So, that is 3EI over L. Okay, theta C. Ito yan, no? So, yung theta R, so theta C. Minus psi on CD plus the fixed end moment on CD minus, okay, kalahati ng fixed end moment sa DC. Substitute natin. Substitute. Okay, so this becomes 3EI over L is 5 theta C minus, what is psi CD? Psi CD, ito is psi CD. Positive 0.0036. Positive 0.0036. Okay? Then plus, what is the fixed end moment for CD? O CD, uniform load uli. WL square over 12, diba? W is 32. L is 5 square over 12. So, yan yung fixed end moment sa CD. CD is nasa kaliwa. Kaliwa is counterclockwise yung fixed end moment. So, that is positive. Minus kalahati ng FEM sa DC. Ano yung FEM sa DC? Diba? Parehas lang yung magnitude. 32, 5 square over 12. Pero, that is nasa kanan. That is clockwise. So, that is clockwise. So, that's negative. Yan. So, simplifying this one, this becomes 3EI theta C over 5. Okay. Then, 3 over 5 times 0.0036. So, we got minus 0.00216 of EI. Ito yun. Then, this one would be 32 times 25 over 12 minus, so magiging plus 32 times 25 over 24. So, we have plus 100. Ayan. So, that would be our fourth equation. Ayan. So, then, actually, yung huli, yung MDC, moment sa DC is 0. Kasi dulo siya ng beam, tas roller, tas wala namang external moment applied. So, 0 siya. Okay, so, these are the slope deflection equations. So, next would be, ano ngayon yung mga equilibrium equation natin? So, let's move to equilibrium equations. Okay. So, ano equilibrium equation natin? Hindi ba doon sa support B, dapat yung moment sa BA, pag inad ko sa moment sa BC, dapat ang sum nila 0? Diba? Ito yun. Okay. So, ano yung MBA? MBA is equation 1. Equation 1. Kopyahin ko equation 1. 3EI delta B over 5 0.0018 of EI minus 100. So, yan yung BA. Ano yung BC? BC. Ito na yung BC. Ito yung BC sa baba. No? So, kopyahin ko lang yung BC. Ito. So, plus 4EI theta B over 5 plus 2EI theta C over 5 plus this one plus 00504 EI plus 200 over 3 should be equal to 0. Okay, should be equal to 0. So, simplify lang natin to. By the way, ano ba yung EI? Ano ba yung EI? What is EI? Okay, E is 200 gigapascal or kilonewton per mm square. Ano yung I? I is 1705 given to. 1705 million. 1705 times 10 to the 6 mm to the 4th. Okay. Para siya maging consistent dun sa unit ng moment natin na kilonewton meter, gawin natin tong kilonewton meter. Kasi makakancel yung mm square sa mm to the 4th, kaya ang maging unit itong EI na to is kilonewton mm square lang. So, para siya maging meter square, so 1 meter, diba, is equivalent to 1,000 millimeter. Tapos i-square ko sila parehas. Kaya yung EI natin, mangyayari dyan is In terms of kilonewton meter, 200 times 1705. Cancel yung times 10 to the 6 at saka yung 1000 square. So magiging EI natin is 341,000. That's kilonewton meter square. So yan yung unit ng EI natin. Yan yung gagamitin nating EI dito sa mga EI values na to. Okay? So when we simplify this one, theta b, so add natin. So 3 over 5 plus 4 over 5. Okay, so that becomes 7 over 5. 7 EI theta b over 5. Okay, tapos yung theta c isa lang, 2/5. Okay, tapos ito yung may EI, ito rin yung may EI. Pagsamahin ko lang sila. Yung EI ko papalitan ko nito, so magiging constant na siya. So 0.0018 times EI 341,000. So minus 100 plus 0.00504 times EI plus 200 over 3. So ang simplified niyan is plus 17,243 over 75 equal 0. So yan yung simplified equation natin. Let me call that equation number 5 based from the equilibrium equation. So ano pa yung another equilibrium equation? Diba yung moment din sa C, MCB tsaka MCD parehas yun. I mean, pag inad mo silang dalawa, dapat 0 yung moment nun. MCB plus MCD when added should be equal to 0. Ano yung MCB? MCB is ito. Ito yung number 3 equation. Tapos yung MCD yung 4th equation. So i-add ko yung 3 and 4. Kopyahin ko lang ha. So that would be 4 EI theta C over 5 plus 2 EI theta B over 5 plus 0.00504 EI minus 200 over 3. So kinopya ko lang yung equation 3. Yan yung MCB plus MBC. MCD is this one plus, okay, MCD is this one, MCD 3EI theta C over 5 minus 0.00216 EI plus 100. So everything should be equal to 0. Okay, so pag samasamahin natin, yung theta B nag-iisa lang siya. So 2 EI theta B over 5 na siya. Tapos yung theta C 4/5 at saka 3/5 plus 3/5. 4/5 plus 3/5, so 7/5. So plus 7 EI theta C over 5. So ito pag samasamahin ko yung mga constant with EI equals 341. Oh, that would be 0.00504 times EI. So 341. Then minus 200 over 3. Ito yun. Minus this one. Minus 0.00216 times EI. Okay, so this one 341,000 plus 100. So the answer is plus 76156 over 75 equals 0. So let me call that as our 6th equation. Yan. So yan yung 6th equation na natin. So we have equation 5 and equation 6 simultaneous equations. Solving these two simultaneous equations. Solve equation 5 and equation 6 simultaneously, this will give us answer for EI theta B. Okay, so the answer there is negative. This is negative 1562.5302. Samantalang yung EI delta C naman natin is equal to negative 278.853. So hindi ko na pinakita kung paano mag-solve ng simultaneous equations. So I assume that you know how to do it. Pwedeng gawin nyo is 2/5 tsaka pwede nyong gawin is i-multiply mo to ng ano ba, ng para maging 2/7, no? Pwede mo i-multiply mo to ng 2/7 para siya maging 2/5 din siya. Everything 2/7. Masolve mo, maka-cancel yung theta B, masosolve mo yung theta C. Then substitute back, makukuha mo yung theta B, EI theta B. Okay? So with that, substituting values, okay, substituting values of EI theta B and value of EI theta C in the slope deflection equations. Okay, so kaya mo ma-solve naman na dyan yung mga moments, diba? So let's say ano yung mga slope deflection equation natin. So of course yung MA B natin 0 na siya. So yung MBA makukuha na natin yan in terms of that would be theta B, EI theta B and EI are given naman. Tapos ganun din yung sa MBC, MCB, MCD, and MDC of course is equal to 0. So pagka sinubstitute mo yan, the values there would be this is negative 432.718. So that means 432.718 kilonewton meter is the answer. Negative means hindi siya counter, so it should be clockwise. Ibig sabihin mali yung direction natin nung inassume natin na counterclockwise, so it would be clockwise. Tinanggal ko na yung negative, tapos nilagay ko doon yung clockwise. Sa BC naman, it would be positive 432.718. So that means 432.718, that's kilonewton meter. Positive, that means tama yung assumption natin, and that is counterclockwise. CB naman, for CD it's negative 800.872. This one is positive 803.87. So that is 803.87 kilonewton meter. Positive, that is counterclockwise. This one naman is 803.87 kilonewton. Negative, that means mali yung counterclockwise, so it would be clockwise. And finally, that would be the 0 moment. Okay, so these are the answers. Then just apply statics if you want to solve for the reactions RA, RB, and RC, and RD as well. So statics, you could reaction sa A, reaction sa B, reaction sa C, at saka reaction sa D. So yun na yung sagot. Okay, so that's how we solve problems with support settlements. I hope you learned something about this video. Okay, so good day. Thank you.